This video is going to cover the second half of the notes, which is exponential regression and then the geometric sequences. So here we have a table, and the table is the population of a village was tracked daily for a week. So we have 7 days on the left side here. And remember, days on tables are not days, but the left side is typically X, but we also know time is usually X as well, so days. The population is on the right-hand side, which is Y. Now, we are able to use exponential regression when we are given a table to create an estimate of what this equation might be. And we can actually use a feature in the calculator for that. And I'm going to be showing you how to do it in Desmos, but I will go ahead and put down the calculator steps because we have learned that before. So to do this with regression on a calculator, you would press Stat, you would press Edit, and then you go ahead and type in your L1 and L2 lists. Now, L1 and L2 would be your X and Y. So list 1 is always X. List 2 is always Y. After that, you're going to press the Stat button. Again, you're going to go ahead to Calc, and you're going to press the menu option for number 0, which is exponential regression. And we've done linear regression, which was number 4. We've done quadratic regression, which is number 5. And then exponential regression is 0. And then you'll press calculate, and it should give you an equation from that. Now, there is a way to do this in Desmos as well, so I'm going to go ahead and show you how to do that in Desmos. So what we're going to do is we're going to type this table into Desmos. Oops, my Desmos is messed up. So I'm going to go ahead and create a table. So to create a table, you're going to press that top left corner where there's a plus sign. Once you press the plus sign, you're going to hit the table button, and you're going to type in the values here. So go through, oops, went too far. 1, 2, 3, 4, 5, 6, 7. You do not want to create extra boxes because it does create errors. So you want to do just the bare minimum here. We're just typing everything in. So we have 425, we have 570, 800, 1035, 1650, 2600, 3742. I'll make sure those are all correct. All right, after we've created the table, there is the regression button. So where we pressed the plus sign earlier, right underneath it, you'll notice that there is a little spot there. It has like a line with like some dots. You're gonna press that, and it's gonna bring down a drop-down menu and an equation as well. In the drop-down menu, you can have all types of regressions you can select. Here we wanna do exponential regression because this data is exponential. So I'm gonna press on exponential regression, and it gives us the equation here. We're gonna round the A value to the whole number here, and then we're gonna round the B value to 3 decimal places. And I'm just gonna double check that these are all correct. 425, 570, 800, 1035, 1650, 2600, 3742. All right. So I have the equation here. Again, we're gonna round the A value to the nearest whole number, so that should be 272. Is that right? 272? Yeah, it's 271.9, so 272. And then the B value is 1.44386. We're going to round that to 3 decimal places. So 1.444. 3/4, okay. And I like to use parentheses for this part. You don't have to. If you want to just do the dot for times, you can do that as well. So that is my equation. I did all of that in Desmos. And again, Desmos is kind of nice because it gives you the equation immediately, whereas a graphing calculator kind of gives it to you in parts. It gives you A, it gives you B, and then you kind of have to do it separately. All right, the next thing we see is, what does the y-intercept represent? So the y-intercept as a point is usually written as the point 0, comma number, right? 0, comma something. And we know that that x value is always 0. So we're going to plug in 0 for your x value just to calculate that y-intercept. So we have 272. Let me go ahead and make this a different color. Times 1.444 to the power of 0, because we're going to plug in 0 for the x value so that we can find our y-intercept. Well, that gives us 272. What does that mean? Well, remember earlier, if you look, isn't that just your A value, 272? Your A value, again, from the previous lesson or the previous section of the notes, A means the starting amount, the starting value. So 272 means that we are starting, or we started with 272 people. All right, the next question here is, what will the population be on day 30? So we're going to use that equation above again, but here we're going to substitute in some information. We know that days on the table is time, which is also known as our x value. We want to plug in 30 for x. So using our equation above, 272 times should stop using the same color here. Oops. Let me erase this real quick. Delete. 272 times 1.444 to the power of 30 for your x value because it's your time. We're going to calculate that. I don't know what that is, so I need to actually go calculate it. 272 parentheses 1.444 to the power of 30 is a ginormous number. Hold on, I need to type that in somewhere so I have it. 1,665,653. Now we are talking about a population in a town, in a village. So we want to round, this must be people or whatever it may be, but we want to round to the nearest whole number here. So this would be 537. So 1,665,653, people. That's a lot of people. 1,665,653 people. Now again, that's just an estimate just based off the trend, right? That's all this graph is doing, or all this equation is doing. It's giving us a rough estimate based on the data we gave it. All right, the next half of the page of notes is geometric sequences. Now we talk about geometric and arithmetic sequences back in Unit 2, and those are types of patterns we can have. Well, a geometric sequence is when we have a multiplying pattern. So we're going to determine if a sequence is geometric, either seeing if it's multiplying by something, and if it is, we're going to create a formula for it. If it's not, then we just kind of leave it as is. So the geometric formula, or the geometric sequence formula here, the explicit formula, it looks like this. It's very intimidating, but it's kind of like exponential. So from earlier, I don't know if you remember the y equals a times b to the power of x. You can kind of treat the an like a y, and you can kind of treat this n minus 1 like the x. So these are just like x and y. I know they look a lot more complicated than x and y, but what I'm saying by that is you leave those alone for now. We're not going to really mess with the y and the x in this problem. A here is like your A1. And A in our word problems was your starting or initial amount. So this is like your starting term. Right? It's the first term. That's what A1 stands for. It's your starting term, your first term. So it's kind of representing the same thing as your A from earlier. Well, B earlier was either your grow or decay. This is known as the rate that it's growing by, but we also call that the common ratio. Kind of think about it like a rate. It's multiplying by something, right? So that's going to be the number being multiplied. And it's kind of like B. Now, N can be any term we want to search for. So if I want to find the 5th term, I can plug in a 5 for that n value. If I want to find the 6th term, I can plug in a 6. So n's kind of like the term number. So if I have a sub 3, that means the 3rd term. Or if I have a sub 8, that would be the 8th term. All right, so let's go ahead and answer these questions and answer these sequences. So the first sequence we have is 2, 4, 8, 16. Now I notice that it is a geometric pattern. I know that because it's multiplying by something. So I know that this is a geometric sequence. So I'm going to go ahead and just, you don't have to write this down, but I'm just going to write this down. It is geometric. Can my M look like an M, please? Geometric. There we go. So how is it geometric? Well, what's the pattern? It's multiplying by 2. So I see it's times by 2. That being said, I can go ahead and just write down my formula. So the formula starts with a sub n equals, right? So we're going to leave that a sub n. We're going to treat that like y equals. We're going to kind of leave that alone for now. Your A1. Now, A1 is your starting term, right? Well, our starting term in this pattern is 2. Open parentheses, our common ratio, the number being multiplied. Well, in this case, the number being multiplied is also 2. That's just a coincidence. They're not always going to be the same number. And then we have n minus 1 as our exponent up here. Sorry, I had to change that back to blue so that my equation was uniform and you weren't confused on where things came from. There we go. The next question is, what is the 15th term? So to calculate the 15th term, I'm going to plug in 15 for that n value. So that's going to be 2 parentheses 2 to the power of 15 minus 1. And more specifically, this A15. So I'm plugging in 15 for n. That doesn't really mean anything, this part, because that's just basically saying what the 15th term is going to be. I just need to plug this into Desmos. Now, when I plug into Desmos or my graphing calculator, whatever, it typically likes this to be simplified. So 15 minus 1, do we know what that is? That's 14, right? So it's going to be 2 parentheses 2 to the power of 14. So I'm gonna go ahead and type that into Desmos, and I'll show you what I mean by it doesn't like it. So if I try to type in 15 minus 1, it's always going to bring that minus 1 down instead of being in the exponent. So we want to go ahead and just simplify and make it a 14. So the 15th term would be 32,768. Oops, I need to clear my calculator out. 32,768. That would be the 15th term. All right, let's move on to the next one. 171396. This is definitely not a multiplication pattern. It's like subtracting by 4, subtracting by 4, and then subtracting by 3. It's not even an arithmetic sequence, so it's not any type of sequence we want. This is not geometric. We can't make a formula if it's not geometric. So can't do anything there. So we're gonna move on. 3, negative 6, 12, negative 24. Now, if this one is geometric, and the pattern here is that it's multiplying by negative 2. What does that mean? That means I have enough information to create my explicit sequence formula. A sub n equals my a value. A1 is going to be your starting term. So in this case, it's going to be 3. Open parentheses. The rate here, the ratio is negative 2. That's what it's multiplying by, to the power of n minus 1. So that is my formula. The next question here is, what is the 10th term? So using the formula up top, we're going to plug in 10, right? So a sub 10 equals 2 parentheses, that's not a 2, that's a 3. 3 parentheses negative 2 to the power of 10 minus 1, because we're looking for the 10th term. Now again, Desmos does not like it non-simplified. So 3 negative 2 to the power of 9, because 10 minus 1 is just 9. So to find the 10th term, that's all I need to plug in. So 3 parentheses negative 2, close parentheses, to the power of 9. Negative 1,536. And that is my 10th term.